So let's go to our board, right, and then see how this k is being chosen. Okay, so let's come here. Let me actually do this, right? So choosing k, right, in K-means. All right, so choosing k in K-means. So let's see how this is actually done. Now, remember that earlier when I was talking about this, this within group, right? This within group sum of squares. Now, if you think about the linear regression, right? If you think about the linear regression class, remember that we were talking about minimizing, right? We were talking about minimizing. We talked about minimizing the root mean square error, right? We talked about minimizing the root mean square error, right? Remember that, right? In this particular case, right? And even in the logistic, right? In the logistic, we talk about in the logistic regression, we talk about minimizing the log loss, right? We talked about that, or the cross entry. All right. So in this particular case, right, the k-means, when we take the k-means, what we try to do is to minimize, right? Is to minimize the within group, right? The within group variance. That's what we try to minimize, right? To minimize the within group variance. Now, what do I mean by minimizing the within group variance? What I mean by that is this. If we pick this, right? Let me try to draw this. So let's say this is we have some random points in here, right? Okay, let me draw another one here. And then we have another point in here. Okay, now this is what we have. Let's say we have centroid here, right? Let's say we have one centroid here. If we have one centroid, it means that we have one group, right? We have only one group, right? And let's say we have say 3 centroids, right? Let's keep 3 centroids here, right? So it means that here we are going to have 3 groups, right? And here we're going to have only one group, right? So what I mean by minimizing the within group error is this. If you consider this one to be the mean, right, to be the mean of all these points, right, to be the mean of all the points that you can see in here, right, what happens is that if this, we pick each of the points, right, so if we pick, say, this point, right, this point represents, say, x, right, this is another x, this is another x, this is another x. So what we are trying to do over here is that if you pick any point, if you pick any x, and then you subtract the mean from it, right, and then you find the square of that, right? So this is just for one point, right? So if you want to do, you will do it for all the other points, right? You do it for all the other points. So that is going to be the summation of all the other points, and you divide it by the total number of points that you have in there, right? What we are trying to do is to minimize this, right? What we are trying to do is to minimize this within group error, right? I mean variance, right? Within group variance. So the distance between this x and the centroid, right? And the centroid, right, is the variance, right? How it varies, right? It's the variance. So we try to minimize this, because if this point is closer to the centroid, it means that it's actually going to be more similar to the others, right? It's actually going to be more similar. So we want all the points, we want all these points to be closer, to be very close to the centroid, right? So that we know that they are all similar to each other, right? They are more closer. Remember that we use distance measures. So if this point is, say, 5, and then this distance, this x, right, from the centroid is, say, 5, and this one is, say, 5.5, and this one is, say, 6.5, and this one is, say, 5.7, and this one is, say, maybe 5.8, and this one is, say, 4.9, right? Then we know that they are closer to each other. Unlike maybe we have, say, this distance to be, say, 5, 0.7, and then this distance will be say 12, this distance will be say 17. Then we know that this point here is not that closer to this 7 or this 17, right? We want the points to be closer to each other as much as possible. That's why we want to minimize the distance in between each of these points, right? That's the variance. We want to minimize the variance, right? So if we take these 3 points, you can see that this distance will be lesser, right? This distance will be lesser, right? This distance will be lesser because we have we have 3 groups, and each of the points will be associated with a centroid, right? Will be associated with a centroid, and in that case, it's not going to go all the way. Let's say if we have a point here, this point should be traced all the way to the centroid here. No, if we have the same point over here, this point will trace to this, right? And not all the way here, right? If we trace it all the way here, maybe it could be 17, but if we trace it to this point, it could be say 5. Okay. All right, so if we have these centroid points, right, if we have say 3 of them, it means that the within group variance is actually going to be less, right? So as we increase our k, right, that's the k represents the centroid, right? So as k becomes high, right, our within group error reduces, right? Our within group variance reduces, right? Our within group variance reduces, all right, as k becomes high. However, if k is small, right, it means that the within group variance is high, right? This one, the within group variance is high, right? But if k is large, the within group variance becomes small, right? The within group variance becomes small, right? So if k is high, the within group variance reduces and it becomes small. But if the k is small, right, so if k equals say 1, the within group variance becomes high, right? The within group variance becomes high. But we want to actually minimize that, right? We want to minimize that. Now let's see just another demonstration of this that will make it more intuitive and more clear for you, right? So let's say we have this. So let's say we have this, right? Let's say we have this one here. Now, if I consider this point, let's say this is x. This is y, right? And then this is x, right? This is x here. Now, if we consider this part to be the within group, right? If we consider this to be the within group variance, right? So within group V, that is within group variance, and this becomes the various number of k that we want. So that is k over here, right? So k could be 1, right? It could be 2, right? It could be 3, it could be 4, right? It could be 5, right? And so on, right? It could be 5 and so on. Just like we're having over here, right? Where over here we said that k equals 1, that is just having one group, and then k equals 3, having say 3 different centroid and 3 groups. Okay, so this is it. Now if we try to plot this within group variance, right? If you see this, if you see the first one that we have over here, right? Here, if k equals 1, right, the within group variance is large, right? So even if we have say here to be say 10, here to be say 20, here to be 30, that's the within group variance, right? So I'm just choosing a random within group of variance here to be say 50. They are just hypothetical numbers that I'm choosing, all right? So if k equals 1, right? If k equals 1, which is this one, right? It means that we have a high, maybe 50, right? A high within group variance, right? So as k reduces, so if k becomes 2, then the within group variance will reduce, isn't it? The within group variance will actually reduce, right? So maybe it will start to drop like that, right? It will start to drop, right? And if we have k to be say 3, right, it will drop again, maybe to say 10, right? Maybe to say 20, right? So it will drop again, right? It will drop again, right? It will drop again. However, there will be a point where the drop will not be that steep anymore, right? The drop will not be that steep anymore. It will start to flatten, right? So if k equals say 4, right, maybe it will be somewhere 15 or 12, something like that, right? And then if k equals if k equals say 5, right, it will not, the drop will not be that much significant anymore, right? And it's actually going to continue that way, right? The drop will not be that significant anymore, all right? And so as you can see, as we increase, as we increase our k, right? As we increase our k, our within group variance lowers or drops, right? Our within group variance drops, and that's what we want to do. That is minimizing our within group variance, right? That's minimizing our within group variance, right? Within group variance. That's what we actually want to do. However, if we want to choose the k, if we want to know which kind of k to choose, right? We actually call this, right? This is what we actually call the elbow method, right? This is what we call the elbow method. This is what we refer to as the elbow method. Now, if this one actually looks like your elbow, so if you take your personal arm, for instance, right, maybe you have some biceps in there, right, then maybe your fingers will come, right? So you see that you have your elbow here, right? So where your finger bends, where your arm bends, right, where your elbow is, right, that's the point that we want to reach and then select as the number of k. So if you see this one, we can see that the steepness got to drop from here, right? So this becomes the elbow, right? So we can say that, okay, if we choose k equals 3, then we will have the best k, and we will be able to minimize our within group variance, right? We will be able to reduce our within group variance. All right, we're going to see this in the lab and see how we are going to generate this elbow method, how we are going to use this elbow method to actually get our k, the best k, and also be able to minimize the within group variance. We're going to see this in the lab session. All right, so this is basically the idea behind it, right? It just like, it looks like your elbow, and where the elbow is, that's when the steepness of the drop gets to flatten from. That's why we actually choose our k, right? So in this case, our k is actually going to be 3, right? We're going to choose our k to be 3, right, to help us minimize our within group variance. Okay, to help us minimize our within group variance, because if you go beyond that, it's actually not making any significant reduction over here, right? So we just can't stop over here, right? We can just stop over here. Okay, so we will go to the lab. In the next video we will get to the lab and then see how we are going to implement this elbow method, and with everything that we've discussed so far, right, from all the way from the classroom to the Kmeans and everything, we're going to actually see it in the lab session, right? We're going to see it in action in the lab session. So see you in the lab session.